Yay, it's now second quarter for our General Chemistry 1 class. This section is on chemical reactions and chemical equations, focusing on chemical equations. In this lesson, we will write equations for chemical reactions and balance the equations. So let's start with the definition of a chemical reaction, in which it is a process in which a substance or a mixture of different substances are converted into new substances. For example, burning of wood, in which the materials in wood are converted to gases, soot, and ash. A chemical equation is the representation of a chemical reaction which shows the chemical formula or formulas of the substances involved. As shown in the diagram, a chemical equation consists of reactants and products. Reactants are the reacting substances before a reaction takes place. Products, on the other hand, are the substances generated after the reaction takes place. In writing the chemical equation, reactants are on the left side, while the products are on the right side. The reactants and the products are separated by an arrow whose head is pointed toward the product, indicating the reactants to indicating the conversion of the reactants to the products or to products. Let us consider the reaction involving the formula of ammonia from nitrogen, and hydrogen gas. To write the corresponding chemical equation, the reactants are nitrogen and hydrogen and are written at the left side of the equation. Note that the chemical formulas of the reactants are separated by a plus sign. The plus sign signifies that more than one substance is the reactant or product. Ammonia, on the other hand, is the product, hence written at the right side of the equation. Another thing to take note in a chemical equation are the coefficients 3 and 2 in ammonia. Coefficients comes before the chemical formula of a substance to indicate its quantity. If no coefficient is written, just like this one, it simply means a coefficient of 1. The equation can be read as 1 nitrogen molecule reacts with 3 hydrogen molecules, yielding, producing, or forming 2 molecules of ammonia. Another way is by expressing quantities in moles, such as 1 mole of nitrogen molecules reacts with 3 moles of hydrogen molecules, yielding, producing, or forming 2 moles of ammonia molecules. For simplicity, when using the unit mole, the word molecules as well as atoms, ions, or particles is no longer mentioned. Physical states of reactants and products can be indicated in writing chemical equations. This is important when one is to carry out the actual reaction. Replacement with the same substance but of different physical state may not lead to the desired or expected reaction. The physical state are written after the chemical formula and are indicated by symbol for S for solid, L for liquid, G for gas, and AQ for aqueous substances or those dissolved in water. Aqueous. This is read as aqueous. For a complete understanding of how the reaction takes place, conditions are indicated above and or below the arrow. These conditions involve temperature, pressure, and other substances that facilitate the reaction. In writing a chemical equation, one must make sure that it is balanced, meaning the number of atoms for each element on the left and right sides is equal. When a given chemical equation is not balanced, the coefficient of the substances can be adjusted. How coefficients are adjusted is usually done by a trial and error approach. This approach is known as balancing by inspection. Before you proceed to balancing chemical equations, make sure that you can write chemical formulas for elements and compounds given their names. Writing the chemical formulas are necessary in writing chemical equations. So let's have the practice problem for balancing chemical equations. Alright, so let's do some balancing chemical equations practice problems. So if you are going to analyze this one, okay, let's go back. The first chemical equation is unbalanced and the second one is already balanced. So let's try to pause this video and examine why it's unbalanced. So if you're going to take a look at C here, okay, 1 molecule of carbon. For sulfur, 1 molecule here, the other one is 2. So this one is one of the reasons why this equation is unbalanced, or this chemical equation is unbalanced. For the second equation, this is balanced. Okay, because if you're going to examine, the same na po ang kanilang moles, no? Like 5 moles of carbon here and 5 moles of carbon as well here, 4 plus 1, as you can see. So let's have this example. Okay, so xenon plus fluorine yielding, okay, this one. So let's try to balance this out. But before that, you try to examine. Xenon here is 1 mole. Here it's also 1 mole. For fluorine 2 here is 6. So this is clearly unbalanced. Alright, so for simplicity, let's just use the word mole for this. Like 1 mole of xenon here, 2 moles of fluorine here, then 1 mole of xenon, and 6 moles of fluorine. So all we have to do is we are going to write all the elements involved in the reactant side and also separate for the elements involved in the product side. Okay, so we have here the xenon, the fluorine, as well as here there's also the xenon and there is also fluorine. So after that, after enumerating the different elements involved, just write the number of moles for each. So for xenon here, as you can see, it's 1. Alright, and the xenon as well here is also 1. Okay, anyway, sinulat muna niya lahat yung involved sa reactant side and afterwards the ones involved in the product side. So as you can see, it's it's unbalanced, no? Kasi in the fluorine, there are 2 moles in the reactant side. For the product side, or in the product side, there are 6 moles of fluorine. So we need to adjust the coefficient, their coefficient, for us to have a balanced chemical equation. Okay. Before we proceed, we are not allowed to change the subscripts. We only are allowed to adjust the coefficients, no? Okay, so let's just okay, so here, since there are 6 fluorine in the product side, all we have to do is, since there's already the 2 subscript here, we're going to think of a factor that will arrive at 6. So it could be 2 times 3. So we are going to put the 3 in the coefficient side. That will give us already the 6 moles of fluorine for the reactant side, and that these 3 here balances out the whole chemical equation, as you can see. Okay, so 1 xenon for the reactant side, 1 mole of xenon in the product side, 6 moles of fluorine in the reactant side, 6 moles of fluorine in the product side. So this chemical equation now is balanced. Let's have another example. Okay, we have here another chemical equation. As you can see, okay, enumerate niya lahat na elements involved. Okay, elements involved in the reactant side, elements involved in the product side. Okay, 1 silver, 2 hydrogen, 1 sulfur. In the product side, 2 moles of silver, 1 mole of sulfur, and 2 moles of hydrogen. So if you're going to take a look at the silver, it's unbalanced, no? So 1 mole here, 2 moles in the products, in the product side. So we're going to think of a factor that can, coefficient that can balance this chemical equation so that the silver in the reactant side will equal. Yes, that's 2. So if you're going to take a look, this time silver has 2 moles, the same number of moles in the product side. So this chemical equation is now balanced. Okay, so another example. Okay, this time there's a lot of oxygen, so we need to consider each one of them. So again, first thing to do, enumerate all the elements involved. Okay, we have potassium, oxygen, hydrogen, then we have carbon. No need for us to write the oxygen again because we have oxygen already written. Okay. Okay, another thing to consider to avoid confusion, kung paano nyo ina-arrange yung mga elements in the reactant side, like potassium followed by oxygen, gawin nyo rin sa product side para hindi kayo malilito. Okay, kahit na after the potassium, yung carbon ang second here in the product side, right? But let's just follow the arrangement in the reactant side para to avoid confusion. So KOHAC, then here we are going to follow as well KOHC para again to avoid confusions. Okay, now let's enumerate. There's 1 mole of potassium, and as you can see for oxygen, 1 mole here plus 2 moles here, a total of 3 moles of oxygen in the reactant side. For the hydrogen, 1 mole, carbon is also 1 mole. In the product side, there are 2 moles of potassium, and for oxygen, 3 moles plus 1 mole, that's equal to 4 moles of oxygen in the product side. For hydrogen, there are 2 moles and carbon 1 mole. So this is very clear, very unbalanced, no? So this is unbalanced chemical equation. Let's balance this out. So let's do the trial and error method, okay? So if you're going to analyze, the potassium in the reactant side is 1, in the product side it's 2. So let's try to put 2 as the coefficient in the potassium here, or in this compound here. So potassium is already 2 in the reactant side, balancing with the 2 there in the product side. And take note, lahat na involved na elements in this compound, since meron na siyang 2, no? Meron na siyang 2 coefficient, ma-distribute itong coefficient. Hindi lang siya take effect sa potassium alone. Ma-affect din niya ang number of moles ni oxygen at saka ni hydrogen. Let's continue this in part 2 kasi parang naubos na ang recording time natin. Let's continue in part 2.